Hey everyone, welcome back. I hope you're all doing great. In today's video, we're going to dive into a new method for scheduling construction projects, the linear scheduling method, or LSM for short. But first, let's take a look at the learning objectives for this lesson. First, we'll talk about linear activities and linear projects, what they are, their characteristics, and how they differ from nonlinear projects. Next, you'll learn about the linear scheduling method and how to use it to create a project schedule. Finally, you'll get the chance to apply this method to a few examples to see how it works in practice. In this video, we'll focus specifically on the first objective, defining linear activities and linear projects. The other two objectives will be covered in the next videos. Well, linear scheduling method, LSM, is a scheduling technique specifically designed for linear projects. These types of projects have unique characteristics that make traditional methods like Gantt charts and precedence networks less effective for managing them. Now let's talk more about linear construction projects. In simple terms, linear projects involve tasks that are continuously repeated along the project's alignment. This could include building highways, railroads, pipelines, and tunnels. For example, when constructing a road, you can't pave the entire road all at once. Instead, you divide it into smaller sections and work on them one by one without any gaps in time between sections. That repeated paving process is called a repetitive activity or linear activity. Other examples of repetitive activities in a roadway project include surveying, excavation, and subgrade preparation. I want to clarify that you can still use methods like Gantt charts for linear projects if they better suit your needs. So what would a Gantt chart for linear project look like? Let's take tunnel projects as an example. They are considered linear projects because construction progresses continuously along their length. Before we dive into a sample bar chart, let's first watch a short clip to understand how a tunnel is constructed using a tunnel boring machine, also known as TBM. As you just saw in the clip, constructing a tunnel using a tunnel boring machine, TBM, follows a series of key steps, and some of them require repetitive activities. First, we have TBM setup and launch. The TBM is transported in parts and assembled on-site at the entry shaft or portal. Once fully set up, it starts boring into the ground. Next is excavation and soil removal. As the TBM advances, its rotating cutter head grinds through soil and rock. A conveyor belt system behind it removes the excavated material, carrying it to the surface. Then, we move to tunnel support and lining. To prevent collapses, the TBM installs precast concrete segments along the tunnel walls. These segments form a reinforced ring, ensuring the tunnel remains stable. The TBM then continues forward, repeating this process excavation, soil removal and lining, until it reaches the endpoint. Finally, we have TBM retrieval. Once the tunnel is complete, the TBM is disassembled at the exit shaft and lifted out piece by piece. In some cases, if retrieval isn't feasible, the TBM may be left underground in a specially designed chamber. And that's the complete sequence of tunnel construction using a TBM. Here's an example. Bar chart schedule for a tunnel project. The first column lists all the activities, which are represented as horizontal bars along the timeline. Different colors can be used to distinguish different types of work. For example, orange is for site preparation, while blue indicates shaft construction. Now take a look at the first column. You'll see activities like preparing the south site, constructing the south shaft, and similar tasks for the north site. Then we have TBM assembly, tunnel excavation and lining, and TBM retrieval. These are the main construction tasks. Beyond that, there are other activities, like the punch list, which outlines the final tasks that need to be completed before the project is officially finished. This typically includes minor fixes or corrections. Finally, at the bottom, you'll see the substantial completion milestone, which marks the point when the punch list work is done and the project is ready for final approval. As you can see here, we can still use a Gantt chart to schedule a linear project. Now, let's take a closer look at this bar chart schedule. What are the linear activities here? Remember, linear activities are tasks that are continuously repeated along the project alignment. In this case, the only true linear activity is tunnel excavation and lining. Other tasks, like site preparation or shaft construction, are repeated, but only twice and not in a continuous flow, so they don't qualify as linear activities. So, is there anything wrong with using a Gantt chart for this tunnel project? Not necessarily, but one key piece of information is missing: location. For linear activities, progress is often measured by location rather than just time. For example, when the TBM reaches the north shaft, that signals 100% completion of the activity. This is a unique feature of linear activities where progress can be visually tracked by location. However, on this bar chart, there's no way to see location, which is why the linear scheduling method, LSM, is often preferred for projects with linear activities, as it preserves both time and location information, making it a more effective tool for these types of projects. Alright, that's it for this video. We covered some key definitions related to linear projects and activities. Thanks for watching, and we'll see you in the next video. Goodbye.